This is Ramnath Mani with yet another episode of the evolution of industrial automation in India. Today, I have with me a guest, Ranjan Kumar, who has been a veteran in the automation industry and has more than 45 years of experience. He is a graduate from Jadavpur University, having done his specialization in control systems, and then MTech in operational management from IIT Delhi. Between 1972 to 77, he was with Siemens, and then in 77, he joined Devike Electronics, India's first industrial automation startup. Devike Electronics, as I have mentioned earlier, was later actually had a joint venture with Allen Bradley and was acquired by Allen Bradley, and today is known as Rockwell Automation. Ranjan spent with Allen Bradley and Rockwell Automation, working in project management, manufacturing, marketing and sales, accounts management, and senior level management. And he was the managing director of Rockwell Automation in India till 2007. In 2007, he shifted to ABB, and he was in charge of large customer account management, including global customers like Tata Group globally, while working in ABB. He brings with him an extensive experience in the industrial automation industry, and today I would like him to share some of his experiences as he has grown in the automation industry from 1977 onwards. Ranjan, you have been a pioneer in the field of industrial automation, having started in the early 70s when it all started. I would like you to tell your background and how you came into industrial automation and what brought you here, and how did you see your future when you took this?
See, in the college at the Jadavpur University final year, I have taken a special paper on automation. There was a special paper which is basically used to explain about the feedback control system with the speed loop, current loop, etc., with all mathematical. And I had a project which is AC/DC transmission. So where basically for a long distance, you need to reduce the loss of, because the AC loss gives capacitance and inductive loss. For a very high voltage 800 kV or 1000 kV DC, then it is only the resistance loss. What it was developed especially in Sweden and some part of Russia, they used to first rectify the AC and then make it DC, and they transmit the DC and then invert it to AC and then feed it back to the supply. So the basic transmission was the DC. So I had a concept of the rectifier and inverter. And again, that time, of course, the water cooled thyristors and all were used. The GE make the big, or ABB make big thyristors were used. So I didn't do the practical. It is basically a theoretical paper. And along with the paper, there the blowers were used. The various kind of blowers are used, which are DC, because the DC current used to go there. So blowers are used to cool the control loom. So that blower basically was a DC motor, and they need to change the speed. So they used to have field control device to control the field. So I did a project which one thyristor and 3 diode, that bridge, and we used to control the speed of the field, and then used to control that. So that was the basic thing which got into my head. And then after passing, I joined Siemens, and there it was all electrical. So I was not getting any output of what I have learned. Then in the meantime, Mr. Palit, who was one of the pioneers at that time, he says that then I explained him this thing. He says there is a company coming up in Bombay, and they are making DC control drives. So will you be interested? I said, I would be very much interested. So then, of course, then long story, I met Mr. Khaitan and group, and then I met you, and then how I joined, and that's how this started. But that was one beginning, and then subsequently, of course, when I was in Siemens, I used to do a lot of logic circuit for a long, for conveyors, for boilers using relay logic. All the logic was used to use relay. Then Siemens has come with static logic, which is basically called schematic, which is basically and or gate. And they did a project which was a real failure of the cement plant and Nagaur and Kachar. But then that time, there was some talk that relays will be replaced by the solid state. And soon, of course, the whole background, how the PLC came. And so I was lucky enough to, that means I think it's turning of my life or my career by joining DBK, which gave me, some insight, which I was aspiring to. That's how I came.
Yeah, very nice. Now, actually, the next question I have is, when you joined DBK, the market was, infant. Nobody
Right.
knew much about drives.
Right.
Who were the other players in India who were actually involved, and how you felt, DBK tackled them, and what are the type of people we had in DBK?
Well, I think DBK, the great thing which we have that, most of the people are from top IITs, from Kanpur or Kharagpur, and I think one from Madras. But mostly it is Kharagpur and Kanpur. I am, of course, from Jadavpur. I'm not an IIT. So the students are all brilliant students. And of course, the company gave a free hand to do anything you would like to do. So that was one of the biggest thing which we had. And that's how people can start thinking of out of the box. And that I think that is one of the innovation we get. And the main challenge was L&T. L&T, Mr. Dravid, well, and Mr. Dravid was, he was a pioneer at that time, and L&T. Siemens has not yet come. They were still thinking. There was ECIL was also very recent. Mostly I think it is mainly it was L&T, and of course there were imported equipment there. And especially the application was, I think the variable speed drive application was best suited for the paper industry, because where to maintain the constant torque, and you need the various at paper machine, and you know much better than me, at various levels you need to control the speed to get the uniformity of the paper. So that's one of the unique application. And the great breakthrough which I think DBK got from West Coast Paper Mill. And incidentally, Mr. Murthy was also involved, and then Mr. Murthy. So that all put together, it was a big leverage. Though DBK was not known to anybody, but because of the technology, I think it is a pure technology which and the passion of the people. Because I think L&T we could beat because the DBK people were more in terms of sales. And another thing which is very important, that normally also in automation, the people who are selling has to be very, very technical. If a normal salesman, can go and talk to people a switch gear, or even if you sell motor, you may not understand the deep philosophy or the physics behind it. But whoever is selling an automation system or a drive, they need a deep knowledge of what he is selling and the application. I think that is one of the score which we had. We had a very good sales team. And of course, you are the leader. But apart from that, all the engineers who are designing, like P.K. Dasgupta or Reshmi Singh or Arun Ghosh or Jain, Ashok Jain, they are a brilliant engineers, but also they are when they go to the front of the customer, they can explain and they can really see the customer. Now we are talking the customer pain point. They can really understand the customer, which I think was lacking in L&T. If I don't know whether I'm correct or wrong, but we think which is the leverage, and we could really take a challenge. If the customer gives a challenge, we could challenge it and prove it that we can do that. I think that's one of the key things. And of course, we had a free hand of doing anything, which is next.
Good. Now, coming back to the ABK and its drives, I think essentially they had a pretty good market in the paper industry. And then, of course, it moved to cement, and then metal industry, etc. Now, how did you see the technology developing at that time, which would lead to the next level of technology?
You see, I think one thing was very, if you see when we started drives, it was analog technology. And normally in analog technology, you need to have a lot of setting points. In fact, that time, it was just an op-amp based and transistorized. The IC, the microprocessor control was not there. So the shift of digital analog to digital technology, which is known that it is coming. So I think that's one of the swing. And also, I think that time in the drives itself, there are a lot of logic we used to use with relays. Which used to malfunction, we used to delay. And customer actually the many things you must be knowing that many a times we have to build a drive in the customer premises, because whatever was the specification, customer change it once the material arrives there. That means they want to change the whole logic because they may not be knowing, or the person who designed it, or from our side have been spoken to the owner, whereas the person who is running the plant is thinking differently. So many a time we have to strip the whole panel and do it again. So I think the programmability of the equipment was one of the things which I think internally we could realize that if we can program based on the customer requirement and change it at a very small instant without any trouble. So one was the digital, and second is the programmability. I think these two change, kind of forces us, or also this is something we knew ahead of the market by interacting with the customer, whatever sense, or maybe by the God's help, whatever. But I think this is something which helped DBKR to be the leading technology, because we could understand, because it's just like telephone jumped to cell phone. We from a dial telephone, we didn't go to electronics. India jumped to cell phone. So here from the relay panel, we switched off to the programmable controller without going to the static logic phase, which many of the companies like, and I don't want to mention them, Siemens or even ABB, they went through that phase. So which also really helped us, and which gave us the leading edge.
Do you remember anything that was most challenging during your period in DBK while we were the drives, in the 70s, early 80s?
Well, I think, there was obviously challenging. I could realize that in a paper mill, normally I can remember the Bhadrachalam paper, because I was involved there, that, breakage of paper, and of course that time, we have, from that MR, we have switched to CKNR, the technology has changed, but the continuous breakage of paper, because the line was not synchronizing properly. So the synchronizing of the drives was one of the biggest challenge which I as a person faced, but obviously many other people have also faced. And there was another thing which is very important, and which is very, we can say that, we sometimes we think how stupid, because there is a mill, Rati, I don't know whether you remember in Bombay, where we were commissioning, and as soon as you turn on the drive, everything used to fail. The fuse used to bloom like a boom. And many people visited and couldn't find out, and customer was very unhappy. So that was one of the big challenge. And luckily I was that, of course I was not involved, luckily I was there present that time, and people used to switch on and come out from the room because the fuse will blow, and thyristor didn't blow. Then I think Desbir Singh came, and I think first he told that they will bring a blower and clean everything, removed everything, and then cleaned the motor, cleaned everything was clean, and it boomed. So that these are the two major experience. I mean, I can see I personally have faced.